Okay, so we're going to start PT graphs or DT graphs. PT stands for position time, DT stands for distance time. For our purposes, they're the exact same way. They're both a way of representing the location of an object. And when we graph it, we get information about the motion, okay? And depending on what you're working on, some resources do a lot of stuff with PT graphs, some of them do them with DT graphs, but they really are representing the same pieces of information. So I want to remind you that we just went through quite a number of exercises, from oil drop drawings to numerical tables of data to our summary sheets to thinking about how do we describe the motion of different objects. And when we're looking at the graphs, we've already looked at graphs. We just did the at rest, the constant velocity, the speeding up, the slowing down with constant acceleration. We did those graphs and we worked through them. There is nothing new that we're going to do here. And we're just looking at it from a slightly different perspective. Before, we were looking at everything we knew about an at-rest object. Now we're going to look at just position time graph information and say, well, what do we know about the motion of the object by just looking at the position time graph? And it may not be doing the same thing for the whole amount of time, because like when you're driving a car or riding in a bus, the vehicle starts and it stops and it speeds up and it slows down, and sometimes it's going at constant velocity and sometimes it's not. And so we're going to be looking at our position time graphs. This is considered a very important standard for sophomores in high school, and this is something that you do tend to see on standardized testing. And so I think it'll be very valuable to you. But I want to remind you, there's nothing new here. This is probably one of the sections that tends to challenge most of the students in this class. But I think normally everybody gets it, but I don't want you to panic. Okay. So we're going to start on green page 16. We're going to talk about position time graphs. This is a doodle note sheet. There's everything on here you should be able to do without my help. I'm going to give you some instructions, and I'm going to ask you to pause the video and actually fill in the numbers, do the number crunching on your own, and then I'll go over the answers. But I think it's very helpful to you to just remind yourself you know how to read graphs and get all this information. So the first thing here says, read the graph to find the position. So it asks you, what is the position of the object at t equals 5 seconds? So if we look at this position time graph and we go over to 5 seconds, we should be able to read what the position is, and we can write that value here. And be sure to include the units and the direction. Then it asks you for t equals 10 seconds, and you can read that from the graph, t equals 20 seconds, t equals 25 seconds, okay? So that's this portion. Then the bottom portion asks you to find the average velocity between two times that are given. And remember, average velocity equals distance divided by time. So you're going to want to figure out the distance, so the location that the object was at the final point at 5 seconds, and subtract from that the position it was at 0 seconds, and then divide that by the total time, which in this case is 5 seconds. Okay, and you might end up with a negative number. Okay, also remember that you've got a direction here. Velocity is a vector, it has direction. And you're going to do that for all three of these. So please do just a little bit of work here. Challenge yourself to do all of this, and then I'm going to give you the answer key and go over it. So pause the video now. Okay, well, hopefully you went through all of this and you took a look. So what I'd like to do is go over this. So at t equals 5 seconds, we have 0. The object is at 0 meters. At 10 seconds, it's at 20 meters east. 20 seconds, it's 100 meters east. And 25 seconds, it's 90 meters east. And I will go over all these things that was written in here in just a few moments. So t equals 0 and t equals 5 seconds. We have, it hasn't moved at all. So is it 0 meters and 0 meters? And so it's at rest. They use the word stationary. I'm using the word at rest. t equals 10 and t equals 14 seconds. Well, they estimated 84. If you're close, it's good enough. And then they said 20 meters. So they end up with 16 meters per second east. And then for the third one, they have 90 meters minus 100 meters. They've got negative 10 meters over those 5 seconds. So they're going to end up flipping the east because they've got a negative here, and they're going to make it a west. So a negative east becomes a west. They have 2 meters per second west. Okay, so let's go over all the rest of this information that's up here. So position time graph provides 2 key pieces of information, both the position and the velocity. Remember, so the position is actually read directly off the graph, like you did here. And by looking at the slope for certain intervals, you can find the velocity. So here it says with the reading the graph to find the position, similar to reading coordinates, just be careful with the units and your direction. So be sure that you record your units. They said here that it's just like reading the Y value. Nothing really shattering there. The slope is just like we did in math class, equals rise over run, or change in Y over change in X. So you've got your final distance minus your initial distance over your final time minus your initial time. Positive slope indicates that it's moving in the positive direction. Negative slope means it's moving in the negative direction because positive velocities are moving in the positive direction, and negative velocities are moving in the negative direction. So if we look at the little time intervals, and they did some color coordinating here to kind of help with some comprehension here. So you've got a flat horizontal line here, and the position hasn't changed. And from that, you know that the object is stopped. And in this little portion next to it, the object is not stopped, and it's not moving at a constant velocity because it's not a straight line. It's actually accelerating in this section. And then we've got this straight line portion, and it is also a constant velocity. And it's pretty steep, so we could call it a fast velocity. And it's actually moving in the east direction because it's moving, its position is getting farther and farther east. And this portion, they call it a deceleration. We're still calling it acceleration, and we're saying it's slowing down. Okay. So in this case, it starts out with that shape where it's traveling at a faster rate, and then it's slowing down closer towards 0, and eventually it stops. So this acceleration curve is a slowing down. This acceleration curve is a speeding up. And these shapes are just like what we did in the summary sheets. And if you're not confident on that, and you're not comfortable, and you don't think you can say that, pause the video and take a look at your summary sheets. Then this last portion is another straight line portion. And so this is a constant velocity. This is a negative slope, and it is moving in the west direction because it's now kind of turned around from 100 meters east and is now heading back towards 90 meters east. Okay, so that is that one. So let's go ahead and do the next one. So now we're on page 17, and I am really not concerned about the story down here at the bottom. So you can ignore all of that. You can just put a big X through that. There's a new idea here. They talk about a tangent line, which is somewhat helpful for those of you who've already covered a tangent line in your math classes. But a tangent line is a line that just touches a curve at one point. And by looking at just what those tangent lines are doing, you can get some relative idea of what the slope of those curves are doing. Okay, that could be a helpful tool for those of you who are comfortable with tangent lines. But if you're not comfortable with tangent line, just go with the shape of the curve based on what we did in the summary sheets. Okay. So this is our position time graph, and there are a number of different sections. So if we take it one at a time and we look for all the horizontal sections, they've kind of colored them in this lime green color. So we've got one here near the beginning, we've got one here in the middle, we've got one here that's kind of on the x-axis, and then we've got one here at the end. All those horizontal lines means that the object is stationary and the velocity is 0. Then these blue sections are types of accelerations. They're curves, so they're not constant velocity. So in this case, this one shows that the object is speeding up because it's getting more and more vertical. It starts out where the object is traveling pretty far, and it's traveling farther and farther and farther. So this is also speeding up. Let's take the next little segment. The next little segment is a straight line, so it's a constant velocity. It's a positive slope. It's moving, therefore it is a positive velocity, and the velocity is eastward. We already talked about this horizontal line. Then we've got this other curve here, and if we look at this curve here, we can say that in this time interval, it's traveled a distance, and then in the next time interval, it has, so this time interval, the object is speeding up initially, it's traveling a distance, and then it's traveling a lot further in the next time interval. But then it starts slowing down, okay? So it starts slowing down here and starts heading towards 0. So while all of this is an acceleration, the first part is a speeding up portion, the last part is a slowing down portion, and it's heading towards going to a velocity of 0, and it's going to be a flat horizontal line. So here we've got a stationary object, and then this next portion, we have a straight line that is indicating a constant velocity, and it has a negative slope. Remember, positive slopes are like this one, negative slopes are like this one, and this object is moving in the west direction, so we know that it has a negative velocity. So we can tell a lot by just looking at this graph, okay? We know that the velocity is equal to the slope of this graph, and we showed that on the other page. So basically, we could, if I wanted you to, write a story, which is what they do on the bottom of this page, as they go through talking about what happens at each time interval for this, okay? So before I do the next part, I'm going to go ahead and pause the video and record the last page in this section, because this is a lot for one video.